Hello, this is one of a series of short videos produced by XP Power in response to questions received by our applications team around the world. We hope you find them useful. My 10 kV power supply has an isolation rating of only 3,500 volts. Why is that? Well, in a typical DC to high voltage DC converter, the DC input feeds an oscillator, which drives a step-up transformer, which drives a rectifier. If this was the extent of the circuit, then the isolation rating should be greater than the maximum output voltage to eliminate the possibility of insulation breakdown. This little tiny thing is a 6,000 volt product from our AG series. It has an isolating transformer, but the transformer does not experience the full voltage potential from input to output, because a lot of it is generated on the secondary side. So how do you safely generate 10 kV on the secondary side without compromising the insulation? Well, instead of a rectifying diode and smoothing components, the transformer output typically drives a Cockcroft-Walton multiplier circuit, which pumps up the charge from the transformer to a much higher voltage at the product output. Here is a circuit diagram. For example, the product with a 10 kV output may have a quadruple multiplier stage. The transformer winding produces 2,500 volt peak and is never subjected to the 10 kV. Notice here that the 0 volt reference at the bottom of the multiplier is the reference for the isolation rating. Can I bias the output circuit to a reference voltage other than ground? Yes, you can. And this is typically how these high voltage products are used in many applications. An example would be the creation of a linear 4-quadrant bipolar power supply producing -2 to +2 kV from two small high voltage modules just like this. With the first module, we create a -2 kV reference by tying the high voltage return pin to ground. I'm using a negative going product here. If we then add a +4 kV module with the output referenced to -2 kV, it will generate a voltage that can be linearly adjusted through the full 4 kV range without any major non-linearity or delay or hiccup as it passes through 0 volts. This approach avoids the expense and the space required for a typical off-the-shelf bipolar supply. One important point I must mention: never leave the output floating on one of these high voltage supplies with the power on. The output may electrostatically charge to a voltage in excess of the isolation rating and damage it. Another question: how can I test the isolation of my high voltage configuration? Well, on a very practical note, we sometimes see power supplies of all varieties reported to us as damaged during an electric strength or hypot test. So here is how to run your electric strength test without damage. Point 1. Connect the supply and the return pins of your input together. 2. Connect the output and the return pins of your high voltage output together. 3. Add a leakage detector, either a known high resistance with a voltmeter or a current meter with a low nanoamp range. 4. Connect a high voltage source and slowly wind up the voltage from 0 to the isolation rating of the product, never above. Check your measuring instrument and then wind the voltage down just as slowly. And finally, ensure that everything is fully discharged before it is touched. In conclusion, these galvanically isolated high voltage modules provide a low cost, off-the-shelf building block for creating bipolar or multiple output high voltage configurations. My name is Alan Hill, and I hope you found this video helpful.